Hello everyone. Here we will do some problems related with bearings where in some of the problems we have to use calculator. Now let us see the first question. The first question is the diagram shows a triangular field ABC on the horizontal ground. The angle BAC is given. Angle BAC is given 82.8 degree. This is 82.8 degree. The bearing of C from A is given 210. So from A, if I draw an angle, say I draw an angle like this, then this angle is given 210 degree. Okay, we have to find the bearing of B from A. So this is for 1 mark. It's quite simple. Bearing of B from A. So it is 210 degree minus 82.8 degree. So 210 minus 82.8 is 127.2. So this is 127.2 degree. Okay, now I discussed with you that bearing should be in 3-digit format, but 3-digit format is for integers. So after decimal we can write 1 digit. So 127.2 is the bearing of B from A. Now find the bearing of A from B. So once you get bearing of B from A, which is less than 180 degree, so bearing of A from B, for that what we do, we will simply add 180 degree to this 127.2 degree. So after adding 180 degree, the result is 307.2. 307.2 degree. Okay. Second question is the diagram shows a field ABCD on the horizontal ground. The angle CAD is 35.8 and the bearing of D from A is 70. Okay, before that, here those who have already seen bearing questions which I did using non-calculator based problems, there already I discussed the concept that if your bearing is less than 180 degree, then to find the bearing in reverse order you have to simply add 180 degree. So here, without doing much effort, I simply added 180 degree. Now here in this problem, the diagram shows the field ABCD on the horizontal ground. The angle CAD is 35.8 degrees. So here this angle is 35.8 degree, and the bearing of D from A is given 70 degree. Okay, so this whole angle is 70. Now we have to find out the bearing of A from C. So bearing of A from C. So from C, I need to find out this angle. So if I get bearing of C from A, then it is easy for me to get the bearing of A from C. So here you can see that bearing of C from A, I will say that bearing of C from A is 70 degree minus 35.8 degree. So 70 degree minus 35.8 degree, 34.2 degree. This is bearing of C from A. So therefore bearing of A from C, as this angle is less than 180, I will add 180 degree to this 34.2 degree. So plus 180 will give me 214.2. 214.2 degree. This is your required bearing. Now in this problem, the diagram shows a field ABCD. The bearing of B from A is given 140. C is due east of B. Okay, C is due east of B and D is due north. So here between this and this there is 90-degree angle. I will draw north over here. So this whole angle is also 90-degree. Now the lengths are given on the diagram. We have to find out the bearing of D from B. So I will simply join this BD, and here I find out what is this angle X. So using trigonometry, I can say that my tan X will be 450 divided by 350. So this gives me angle X. So X will be tan inverse. It is going to be tan inverse of 450 divided by 350. So keep your mode in degree and then tan inverse 450 divided by 350. So you get your angle as 52.1. So this is 52.1 degree. Okay, up to one decimal place. Now bearing of D from B. So therefore bearing of D from B will be equal to 90-degree minus your X, which is 52.1 degree. So 90 minus your answer is 37.9 degree. So this is 37.9 degree. Now in this problem, the diagram shows the positions of three towns: Acton, Barton and Colton. I will say ABC. Three towns ABC. Now B is 8 km from A on the bearing of 37. Diagram shows it. And C is 9 km from B on the bearing of 150 degree. Find out the bearing of C from A. The bearing of C from A. So I will join this AC, and bearing of C from A I need to find. That means I need to work out this angle. Say this angle is X. I need to work out this angle X. Then X plus 37 will be the required answer. Now here this angle I is shown as X. Let us consider this angle as here at B it is Y, and this angle as Z. Okay, so one thing I know that your angle Y is 180 degree minus 37 degree. So 10 minus 7 is 3, and then 7 minus 3 is 4. So 143 degree. This is Y. And your angle Z is nothing but it is 360 degree minus 150 degree minus this angle B, angle Y, which is 143 degree. So the value of Z is 360 minus 150 minus 143 is equals to 67 degree. Now to find X, we can use sine rule, but to apply sine rule, I must know the length of AC, or I must know this angle C. Let us assume this angle is W. So your now I don't know X. I know Z. Z is known to me. What I can do, I can find out this length AC. Okay, so better I find a length AC instead of finding your angle W. Okay, which is still is fine. We can do that. Angle W we can find out. Angle X, no. Okay, this AC length we require. So AC, for AC we will use cosine rule. So your AC square is equals to 8 square plus 9 square minus 2 times 8 times 9 times cos of your angle Z, which is 67 degree. Okay, so this is AC square, and therefore the length AC, if I find AC, then it is simply square root of this whole thing. Okay, so length AC here we get 8 square plus 9 square minus 2 times 8 times 9 times cos of 67, then square root of that. So this length is 9.42. 9.42. Okay. Therefore, now this is 9.4242 kilometer. Now your again I need to apply sine rule. So sine of x divided by its opposite side 9 will be equal to sine of z divided by its opposite is 9.42. Now sine z, angle z is known. Angle z is 67 degree. So your x is equals to sine z is sine of 67 divided by 9.42 times 9. This whole, if I do sine inverse, I will get x. So your sine x is sine 67 divided by 9.42 into 9. Therefore, x is sine inverse of all these values. So let us do sine inverse of sine 67 degree into 9 divided by 9.42. So your angle is 61.6 degree. X is 61.6 degree. So therefore, bearing of C from A, therefore bearing of C from A is equals to 37 degree plus 61.6 degree. So 37 plus 66, 61.6, 61.6 is 98.6. Okay, so as it is bearing, I will write 098.6. 098.6. This problem is for 5 marks, and here you can see that we apply cosine rule, we apply sine rule, also we apply some other concepts like sum of interior angle is supplementary, sum of all angles at a point is 360 degree, and so on. So if you have a bearing problem for 2 marks, it's very simple, in 2 steps you can get. But if it is little complicated, then lot of other things you should know. Basically, all the geometrical concepts you must know. Okay, so we will stop here. I hope you get some insight how complicated the problem can be related with bearing. So what I suggest that go and check out different bearing problems which already came into your previous papers and see what different geometrical concepts are applied there. Okay, it is not going to more than 2 or 3 concepts, but you have to apply some extra knowledge to solve bearing problems when it is like 3, 4 or 5 marks. Take care. Bye bye.